Hello, Math 1. This is Mr. Roberts at Shasta High School. Today we're going to look at using our calculators to perform linear regression. Um, on page 164 of your textbook, we have this data table, and it says the table shows a list of average global temperatures for each decade from 1880 to 2009. Um, I'm going to be using the decade numbers 0 through 12 as my independent variables, and I'm going to be using the um, average temperatures as the dependent variable. I went ahead and I already plotted these on a piece of paper. Let's take a look at that. So this is the graph that I created. We set this up in class together, and for homework, I believe on Tuesday night you plotted these points in anticipation for doing the regression with our calculators. You can see that my independent variable is decade numbers from 0 up to 12. And I have temperature. You'll notice that really my temperature values are starting at 67 and going up to, 56 and going up to 59. This small symbol here indicates that there's stuff missing, right? So 0 to 55 is not shown, but 56, 57, 58, and up to 59 are shown on this graph. And then what you're looking at here is just a careful plot of the decade number and the average temperature that was recorded for that decade number. So here we're back at our data table again, and I've decided to use the TI-84. It's the calculator that we have most of in class. I've done a complete reset of the RAM, and that's completely optional. If you want to do that, you can. It's helpful sometimes if there's settings you don't understand. However, if you bring your calculator up to me, I can quickly show you, what's going on with it. We could take a look at the settings together. We're going to begin by entering the data table, and we access that using the statistics button. So stat is right here, and I'm just going to press stat. Once stat is pressed, we're presented with options to edit statistics, do calculations with statistics, or to run some statistical tests. We are going to edit some stat data. So we're going to edit and then option number 1. And you can see we have list 1 and list 2. Now I'm going to go ahead and enter each of these. So each of the values here for my independent variable starting with a 0 and going through 12, I'm going to enter in list 1. So I've got 0, 1, 2, and 3. I'm going to pause the video right now. You might want to pause also so that you can enter in all of those. I have entered the number 12. That's the last value that'll be in list 1. And now I'm ready to jump over and enter list 2 values, which will be my temperatures. So I'm going to press the over key. And once I'm over, I'm going to go ahead and begin entering each of these values. So the first one is 56.876. 56.876. And then press the down button. The next value is 56.642. And then the down button. Then we have 56.732. Oops. Missed the 732. I'm going to go ahead and pause while I enter the rest of the values. Okay, so I've just typed in my last value, and I also went through the list and double-checked each of the values I've entered. Before I leave my edit screen, I want to point out that it's important that you have the exact same number of values in both lists. So you can see my list ends at number 12 for L1. It's the 13th item because I'm starting counting at 0. So it goes from 0 to 12, which is 13 lines. And the temperature for that last one is 58.316. So my data is completely entered now. And I'm going to go ahead and just leave the data. It's done. In fact, before I go much further, I want to take a look at the data as a graph. And one of the most convenient ways for viewing it is to press zoom and then go down to option, I believe it's option number 9, which says zoom stats. Yeah, zoom statistics. So what this will do is it'll look at the lists that are set up in your calculator, and it will zoom to fit that for the graph window. And it just occurred to me that I need to first of all tell my calculator um, where the data is and to turn on a statistical plot. So we're going to come back to zoom in just a moment. Good thought, Mr. Roberts, but we're not ready for that yet. Before we change the zoom, we're going to go here to stat plot. So this is right above the y equals button. So we're going to press second and then go to stat plot. Once we're here, you can see there are several stat plots. I think there's 4 of them. And we're going to turn on the first one. So to turn this on, I'm going to press the enter button on my calculator. And once I'm inside of here, I have the option. You can see the cursor is flashing on, but it is selected to be off. So we're going to turn plot 1 on. So I'm just going to press enter. You can see it now has gone over so that on is the selected one and the cursor is there, it's flashing. We're going to go down to the next group of items. So stats plot is on. I have several different graphs here. You can see we've got a histogram, box and whisker plot. The one in the upper left is a scatter plot, and we're going to be producing a scatter plot with this graph. So we're just going to go down now to the next item. The next one is a place where I can tell my calculator where my data is stored. It turns out that this is correct as it is. My X values were stored in list number 1. Those were my decade numbers. And list 2, my Y values were stored in list 2, which were the average temperature numbers. I can also specify a different symbol for this statistical plot. I'm just going to go ahead and leave this little box. So I'm going to go down, and this is completely now set up for the stat plot. So I'm going to go ahead and hit second and quit. I actually hit mode there. Second and quit. Now that stats plot is set up, I'm going to press zoom now, and now I'm going to go down to option number 9. Option number 9 says zoom stat, and I'm just going to press enter there. And what my calculator does is it basically picks a window that's appropriate for showing all of the data. And if we take a look at our graph in the background here that we plotted, you can see that this is very much mirroring exactly what we did when we plotted this data by hand. So this is a very nice representation of the data. So that's a lot of things that we've done so far. Let's just take a moment to review. We've entered a data set. To enter a data set, we press stats and go to edit. We entered our X values in list 1 and our Y values in list 2. We also made sure that the number of X values and Y values were equal to each other. So you can see that in this case I have 13 items of each, right? The 13th item is decade 12, and the temperature there was 58.316 degrees. After we had entered our data, we turned on a stat plot, and that's, oops, let me leave this. That would be, the stats plot is second and stat plot. Inside of here you can see we have plot 1 is turned on. It is a scatter plot. My X values are being read from list 1, and my Y values are being read from list 2. And the final thing that we've done so far is we zoomed in order to let our data fit the window nicely. So we hit the zoom button, and then we went down to item number 9. You can press the number 9 and just jump to it, but zoom item number 9 is the stat plot, or zoom statistics, and there's the graph that we have. What we're going to do now is 2 things. One of the things we're going to do is something that you shouldn't need to do all the time unless you reset your calculator. The other thing that we're going to do is find the line of best fit for this data. I have made a copy of my graph, just down here a little bit lower. Let me move down here. So this is the graph that we currently have. And what we're going to be doing with our calculator is we're going to be selecting the line that best creates a linear model for this data. And there's just tons of options, as I go through here. I could have a line that's somewhere in here, but to me it feels like it's not really reflective of this higher value. There's some other things going on, but our calculator is a really powerful tool for doing something that's known as linear regression. And at the end of the day, we're going to come up with the equation of a line, right? Y equals ax plus b. So once our calculator generates this, we are going to have both a slope, it's going to give us this value, and it's also going to give us the y-intercept. And those two values will describe this line perfectly. That is the best linear approximation of the data. Now, that doesn't mean it fits it perfectly. For example, you can see with this line I've currently drawn, this particular data point is very close to the line. It's almost on it. But if you consider this data point, there's some error between, if this is my x value, there's some error between what my function is predicting and my observed value. Same thing here. If this is my x value here, my curve, my model is predicting that this is the value of y I should get, right? Y should equal whatever this value is. But you can see that my observed value is up here considerably higher. This is the y value that was observed. So certainly a linear model is not always perfect, and we're going to look at also a way of measuring how good of a model it is, if it's a good descriptor of the data or if it's a poor descriptor of the data. So let's go back to our calculator and do a little bit of housekeeping. We're going to turn on something called diagnostics, and that'll allow us to gauge if our model is a strong model or a weak model for the data that we have. So I'm going to press second, and then down here there's a button right on 0 that says catalog. We're going to turn on a catalog of functions that are built into our calculator. And the item that we want is pretty far down. It's all the way down in the letter D's. So here's A, B, C. There's chi, C, A, B, C, D. Getting closer. Here we are. The value that we have right here is diagnostics, and you can see currently by default diagnostic. Oh no, I'm down to the line that says diagnostics on. So once I'm down at the diagnostics on line, I need to press enter on my calculator, and then I need to press enter a second time. It will then run the small program that turns on diagnostic mode, and it will say diagnostics on, done. So let's continue. The next thing we're going to do is we are now going to perform the actual linear regression and get the line of best fit for our data. So I'm going to go back to statistics, and after I press stats, I'm going to go over to calc for calculate, and I'd like for my calculator to perform a linear regression, which is option number 4. Down, down, down. And then I will press enter and enter again. Now, you may on the TI-84 in the classroom see an extra screen there. Just jump down into where it says calculate and press enter. But let's take a look at the values that we have here. The calculator is telling me that it has found the line of best fit, and it is a line. It's of the form, oops, I want to make this calculator stay on top. So it is of the form y equals, you can see it's got ax plus b, and that's way too crowded. Y equals a times x plus b. Now, on screen, I'm given the values of both a, the coefficient of x, and b, my y-intercept. So I was going to, my data set was 3 significant figures. So if I wanted to, I could go ahead and round this to y equals, for A, I could record 1 point or 0.110x. I'm trying to round to 3 decimal places, and yeah, this would round to 0.11. But by putting the 0 there, I'm indicating that I am recording it to 3 decimal places of accuracy. And then for the B, I'm going to have plus B, which is 56.572. So this is the equation of the line that would best fit the data that we have here. And I'm going to go ahead and graph that equation now on the calculator as well. So to do that, I'm going to go ahead and press. No, before we leave though, I want to. Now let's just do that. We'll come back to it. I'm going to go ahead and press y equals, and I'm going to enter this equation. So y equals 0.11 times x plus 56.572. And I will press enter. And I'm going to go ahead and press graph then. And you can see that it graphs my data points plus this new line of best fit. So this line is the line that the model's generating, right? You can see that there is error here. This is there are points, several points that like 1, 2, 3, 4, 5, 6 are very, very close to it. There's a couple that deviate in an interesting way where it goes up and down and then back up again. And I'm supposing it will probably go down. These curves are probably, if you look at it, probably pretty well following some solar cycles. You know, our sun goes through periods where it's more active and then less active. So I'm probably seeing higher solar activity and then a trough and then up and then down and up. And remember, let's not over exaggerate this. This is, we're only looking at changes from, I think the low end is 56 and the high is not even 59. So from 56 to 59. In fact, it's actually, to say 56 is a misrepresentation. It's really close to 56.6. So really, we're looking at just 2-degree variation in here, and it would be nice to have a much larger data set than this, and from maybe some more data points. But anyways, this is the line of best fit, this model for this function. The one thing that I haven't talked about is this value of r. In our textbook, it gives us it gave us a value of a, b, r squared, and r. And the value of r is very useful for indicating how well the data is represented by the linear function. It's called the correlation coefficient. And correlation coefficients range between values of -1 and +1. So just to kind of talk through this a little bit, if I have a data set that looks maybe something like this, in other words, something kind of like the one that we just had, I can see that in general there's kind of a positive trend here. So I would say that R, the correlation coefficient, is a positive number, and it's getting kind of close to 1. Now, as more and more of these points, if the data set looked different, if more of my points were very close to the line, in fact, most of them were nearly on the line, this would get to where our correlation coefficient is ever increasingly closer to 1, right? And in fact, if I look at R values, R's will range between -1 to +1. A correlation coefficient of exactly 1 means that we are looking at a data set where basically the data is described by a perfect linear function, right? All the data points are exactly on a line. If we have so this is 1. If we have a correlation coefficient that's 0, what we're looking at here is a situation where you've got data, but there's no detectable inherent pattern. Now I can't really see that there's a trend line going up or down. It's just kind of random noise, or there might be something, but we would say that this would be very close to a correlation coefficient of 0. And then the third possibility is you can have a correlation coefficient where your data is on a perfect line, which you have a negative slope. And when we see this, we have a correlation coefficient of -1. So those three that the correlation coefficient is always going to range in there. Certainly with the data set that we have here, I'm expecting to see a positive correlation coefficient. And I also suspect that it's going to be a fairly large number. Not 1, because clearly I have quite a few points that are not on the line, but close. I'm going to go ahead and do the analysis again. So I'm hitting Stat, going to Calculate, and then down to Linear Regression one more time. And when I do it, this time I'm going to notice, I can see it there on that screen, but this time I'm going to notice my value of R. For this problem, R equals 0.8887. Yeah, this is probably rounded to 0.89. So this value indicates that there's a pretty strong case to be made that there's a relationship between these numbers, certainly, and as that one of them is increasing, the other is increasing. And I can use this linear model, for some predictability, for some predictive features in terms of the function. I think we're going to stop right there. These are procedures we're going to be continuing to practice in class. If you feel like you need to, I encourage you to come back and review these techniques, and certainly feel free to talk to me in class anytime if you get stuck in entering values and looking at linear regressions.